Hello Algebra 2 students, this is Miss Prater. I am doing a Unit 2 review and I'm going to use this in a couple different ways, but one of the main ways is I can pull your Unit 2 test part 1, and if anybody did poorly on that, I'm going to send out an email with this video. So again, this is a review for Unit 2, anything in Unit 2, any quiz, the Unit 2 test part 1. This is the PowerPoint that I used when I did it. I worked this in Class Connect, so I'm going to skip a few things and I'm going to jump down to some of the rules that we had in Unit 2. If you will draw your attention to this section that says, remember, it says a radical isn't always a square root. Your brain will default to square root if you are not careful. So if you just see the radical symbol, but there's no little number, so let's go over here really quick. So this little number is called an index. So if you don't see an index, then the radical does mean that it's a square root. The number or the variable that's underneath the radical sign is called the base or the radicand, and then sometimes that radicand has an exponent. So going back to this rule, I put this on this slide because a lot of students struggle if they are having to take the square root or the radical of a fraction. So there is no index written, so no little number. And so that means it's an understood square root. So you're asking yourself what times 2 gives you 81 divided by what times itself 2 times gives you 81 over what times itself 2 times gives you 49. So the square root of 81 is 9 over the square root of 49 is 7. So the answer is 9/7. You always have to make sure that you reduce your fraction. So my first few slides are just going over rules that we had. It says remember perfect squares and cubes. Perfect squares and cubes can be found on your calculator. So 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, and so forth. If you do 1 cubed, you get 1, 2 cubed is 8, 3 cubed is 27, 4 cubed is 64, and so on. These are snips of a TI-84. If you do not have a TI-84, you can use any type of scientific calculator. There may be times in today's lesson that I use my Desmos Scientific Calculator. This is a free calculator that you can Google and save to your toolbar. So if you were doing something like 2 cubed, you would do 2. You would use this key to get to your exponent, and then you would do 3. So 8 would be a perfect cube. If you did 5 cubed, I always do that all the time, type over something. 5 to the third is 125, so 125 would be a perfect cube, and so forth. When we're talking about variables being perfect squares and perfect cubes, that's something that you can't do in your calculator. So if you're dealing with variables, you just have to know the rules for your variables as far as cubing them, squaring them, taking the square root, taking the cube root. Any number that has an exponent that is divisible by 2, like this list, x to the second, x to the fourth, x to the sixth, x to the eighth, x to the 10th, and so on, are considered perfect squares. Any variable that has an exponent that is divisible by 3, like x to the third, x to the sixth, x to the ninth, and this list would be considered perfect cubes. So your variables are completely different than your numbers. You can't take the square root and the cube root and the fourth root of variables in your calculator. You have to know the rules for that, and we'll talk about that today. When we're adding and subtracting radicals, we do have to have like terms. So I would combine these two terms and these two terms. 3 plus 11 is 14, so I get 14 squared root of 5. Negative 5 and negative 2 combine to be negative 7. I can't combine a radical 5 and a radical 7, so I'll leave my answer just like this. So going through some rules, this rule is for adding and subtracting. We're basically combining like terms. My next slide is going to be a rule for multiplying. When you're multiplying, you don't have to have like terms. You're going to multiply the outside numbers together. So 4 and 5 are the outside numbers. They multiply to be 20. And then you're going to multiply the inside numbers and put those back inside your radical. and then you're going to simplify your radical. So this is the understood square root of 16, meaning what times itself 2 times is 16. That would be 4. There's an understood multiplication going on between those two, and the final answer would be 80. We do have problems in Unit 2 where we have things that are raised to an exponent that is a fraction. So remember that the top is the power and the bottom is the root. I like to think about the picture of a tree. The roots are in the bottom, so the bottom of the exponent, if it's a fraction, is always the root, and the top is the power. So again, here's your power, here's your root. So for a quick example, if I have something like 125 to the 2/3, then the 3 represents the root, so this would be the cube root of 125. The 2 represents the power, so I would raise that to the second power. I always do the radical first if I can. The cube root of 125 means what times itself 3 times is 125. That's going to be 5. And then I'm going to raise that to the second power, and then my answer would simplify out to be 25. Next rule is imaginary numbers. So basically, imaginary numbers have 2 main rules. So you could do all problems with imaginary numbers using these 2 rules. I is equal to the square root of -1, and I squared is equal to -1, just the number -1. These last 2 are just some extra things that I throw in for you. If I is raised to an even exponent, it always simplifies to be a positive or a -1. And if I is raised to an odd exponent, that problem always simplifies to be positive or -1. All right, we're jumping in with some review problems. Number 1 is asking us to simplify. We have 3 times the square root of 54. 54 is not a perfect square, so we're going to think about perfect squares like 4 and 9 and 16 and 25 and 36 and 49 and 64 and 81 and 100. I'll go all the way down to the numbers that you memorized, hopefully memorized in the 3rd and the 4th grade. So 54 is not one of these numbers. I know it's not one of them because it lies between 49 and 64, but 9 will go into 54, so I'm going to have to factor 54 into 9 times 6. I'm not going to do anything with my variables, so I'm just going to write those down. And then we're going to do the square root of 9. So remember your understood index is 2. The square root of 9 is 3. So there's already a 3 on the outside. So when that 3 comes out, those are going to get multiplied together. There's nothing that you can do with a 6, so you're going to leave it there. When you get to your variables, you have to divide your index into your exponent. So we're going to do 4 divided by 2. That's going to go evenly. So I'm going to bring out an m to the second. And then I'm going to divide 2 into 5. That's going to go 2 also. So I'm going to bring out n to the second. But 2 doesn't go into 5 evenly. You have 1 left over. So inside your square root, you have a 6 and an n to the 1. They're not going to write the end of the 1 in your OLS. If you want to write it, you can. Don't forget to do 3 times 3. That's going to give me 9, m to the second, n to the second, and then the square root of 6n. Final answer. In number 2, notice that we're adding and subtracting. So remember, our rule for adding and subtracting is that we have to have like terms. The first thing that I notice is that the square root of 18 is not simplified. So I always want to simplify before I combine my like terms. So I can divide 9 into 18, and 9 is going to be helpful because 9 is a perfect square. I'm going to bring down everything else because it's already simplified. The square root of 9 is 3, so 3 is going to come out. There's already a number on the outside. Those outside numbers always get multiplied together, and then I'm left with 9 square root of 2 minus an understood 1 square root of 2 plus 3 square root of 2. These are all like terms because they're all square roots of 2, so I combine the numbers in front. -9 and -1 combine to be -10, and -10 and +3 combine to be -7. And then I keep that like term, which is square root of 2. In example 3, I'm multiplying. So the rule when we're multiplying is we multiply our outside numbers. So -2 times +1 is -2. And then we multiply our inside numbers and we put that product back inside the square root. So I get negative 2 square root of 50. 60 is not a perfect square. It lies between 64 and 81. So I have to find a number that will go into 60 that is a perfect square. And the largest number that's going to go into 60 that's a perfect square is 4. I'm going to take the square root of 4. 2 is going to come out. If there's already a number on the outside, those numbers always get multiplied together. And then I'm left with a final answer of negative 4 square root of 15. Negative 4 square root of 15. 5 square root of 2, 5 square root of 72. I think the reason I picked this one is, let me list my numbers again. 2 squared is 4. 3 squared is 9, 16, 25, 36, 49, 64, 81, 100, 121, 144. So sometimes I forget why I pick problems, but 72 is not a perfect square. I remember why I picked this one now. 72 is not a perfect square. It lies between 64 and 81. But there are two perfect squares that will divide into 72, and that would be 9 will divide into 72, but so will 36. So you always want to pick the largest perfect square. If the number under your square root is not a perfect square, then you always want to pick the largest square root because that's going to shorten your problem. You could pick 9 and then do 9 times 8, but then 8 is divisible by 4, so you would have to simplify again. So I always go with the shortest route. That means that I have less chance of making more mistakes. So I'm going to do 72 is the same as 36 times 2. The square root of 36 is 6. 6 comes outside. If there's a number on the outside, those numbers always get multiplied together. And then my simplified answer would be 30 square root of 2. So those first 4 examples are all square roots. We were either simplifying, adding, or subtracting, or multiplying. Number 5 brings us to a cube root. So if you're not careful, your brain is going to be stuck into the square root mode and you're going to think I'm doing the square root when this problem is a cube root. So the first thing I have to do is I have to almost just slap myself and say, hey, you're doing a cube root. You're doing a cube root. You're doing a cube root. It's not a square root. It's a cube root. So we're not thinking about these numbers anymore. Okay, these are perfect squares. So let me make a quick list of perfect cubes. So you got to tell yourself, okay, 2 cubed is 8, 3 cubed is 27, 4 cubed is 64. These you may not have memorized. Put them in your calculator. 5 cubed is 125. And to be honest, if you can just know 8 is a perfect cube, 27 is a perfect cube, 64 is a perfect cube, 125 is a perfect cube. Hold on just a second. I'm getting a message. Okay. Think about those. So 64, 64 is a perfect cube. That's 3 cubed. So the cube root of 64 is 4. So I'm going to bring it outside the radical. Remember, when we're taking the cube root of our exponents, we're dividing the index into the exponent. So we're doing 12, or 3 divided into 12, or 12 divided by 3. That's going to go evenly. That's going to give me x to the 4th. So that's going to go away. 3 is going to divide into 15 5 times. So I'm going to bring out y to the 5th. And y to the 15th is going to go away. 3 is going to divide into 11 3 times. So I'm going to bring out z to the 3rd. But there's something left over. Okay. 11 is not completely divisible by 3. But 3 times 3 is 9. So when I divide 3 into 11 and get 3, I have 2 left over. So the only thing that stays under my cube root is a z to the 2nd. That's what's left over. So I end up with 4x to the 4th, y to the 5th, z to the 3rd, the cube root of z to the 2nd. Example 6 has a negative under the square root. When we have a negative under the square root, we want to think about that as negative 1 times positive 50. And we know the square root of a negative 1 is the imaginary I. So we would want to bring that out first. 50 is not a perfect square, but 25 will go into 50. So I want to rewrite 50 as 25 times 2. I want to take the square root of 25, which is 5. I want to bring it out and multiply it times that I. And my final answer is going to be 5i square root of 2. These examples are simplifying. These are all have i's or have a negative under the square root. So this is where I told you that if you have I to the even power, that's always going to simplify either into a positive or negative 1. If you have I to the odd power, that's always going to simplify to be plus or minus I. So the only time it's okay to leave an answer in a problem is when I is raised to the first power. So if you have I to the second or higher, anything like this, 2, 3, 4, 10, 100, these have to be simplified. All powers of I, except for I to the first, have to be simplified. So that's what's happening here. I have I to the 72nd. So the first thing I ask myself is this exponent even? And it is. So example 7, we're going to look at what to do if the exponent on the I is even. Example 8, we're going to look at what to do if the exponent on the I is odd. That's why there's two different examples. So if your exponent is even, you're going to rewrite your problem as I to the second. So when we have a power to a power, we multiply. So you're going to ask yourself 2 times what number is going to give you 72, and that's going to be 36. So I squared to the 36th is the same as I to the 72nd. And the reason that's helpful is because I do know that I squared is always equal to negative 1. So I can substitute negative 1 in for I squared, raise that to the 36th power. Anytime you're raising a negative 1 to an even power, your answer is always a positive 1. If I had a negative 1 raised to an odd power, then my answer would always be a negative 1. So negative 1 to an even power always equals a positive 1. Negative 1 to an odd power always equals a negative 1. If you're not sure, let me show you this on the graphing calculator or on the always put your on the scientific calculator, always put your negative 1 in parentheses. And then if we raise this to an even power, what do we have, 36? That's going to give you a positive 1. Always put your negative number in parentheses. So then if I did negative 1 raised to, let's do the 25th power, that 25 is odd, so that's going to give you a negative 1. If you're not sure, use your calculator to check. So final answer for example 7 is 1. If the exponent for number 8, for example, is odd, the first thing that you're going to do is you're going to take that odd exponent and you're going to subtract 1. Step number 1, that's what you do every single time. So you're going to rewrite your problem as I to the, whatever your odd exponent is, minus 1. So that's 18 times I. So if it were I to the 25th, then you would subtract 1 and you would rewrite it as I to the 24th times I. That's always going to be your first step. Okay? Once you subtract 1 from your odd number, you're going to be left with the highest power of I that's even. So then we want to break this I to the 18th. Since 18 is even, we're going to want to break that down into an I squared. So we're going to say 2 times what is 18? That's going to be 9 times I. We're going to replace I squared with a negative 1. Anytime I have a negative 1 raised to an odd power, that's going to give me a negative 1. And then I'm going to multiply that times I, and that's going to give me a negative I for my final answer. On number 9, we have a negative under our square root, so you want to think about that as negative 1 times positive 50. The square root of a negative 1 is I, so I is going to come out and get multiplied by what's outside, so that's going to give me 7I squared. 50 is not a perfect square, but I can break that down into 25 times 2. I'm going to change my 7I squared into 7 times negative 1. That's going to give me negative 7 times the square root of 25 times 2. 25 is a perfect square, so I'm going to bring out the square root of 25, which is 5. The numbers on the outside always get multiplied together, so I end up with negative 35 square root of 2. Number 10, we're still multiplying here, but we're multiplying a binomial times a binomial, so we're going to use the FOIL method, first, outer, inner, last. First, outer, inner, last. And we'll multiply the first two terms together. That's going to give me 14I squared. The outside terms multiply to be negative 8i. The inside terms multiply to be positive 21i. And the last terms multiply to be negative 12. Remember, anytime you get an I squared, you're going to turn that I squared into a negative 1. So that's really 14 times negative 1. So that's going to give me a negative 14. The two terms in the middle both have i's, so they're like terms. I can combine those to be positive 13i. And then we call the negative 14 and the negative 12 the real part of the problem because it doesn't have an I. So you can combine the real part. That's going to give you negative 26, and then you'll bring down the plus 13i. They do like for you to write the real part first and the imaginary part second. In an example 11, we're distributing what's on the outside into the parentheses. Distributing is always multiplying, so that's going to give us the square root of 12 minus the square root of 18. 12 is not a perfect square, but 4 will divide into 12, and 4 is a perfect square. 18 is not a perfect square, but 9 will divide into 18, and 9 is a perfect square. So that's going to leave me with 2 square root of 3 minus 3 square root of 2. And I cannot subtract these two terms because they're not like terms, so I have to leave my answer just like this. All right, that is my last example. I'm just going to kind of scroll back up. Remember, as you're going through this video, the first few slides, go and talk about rules. So rules of radicals. What numbers are perfect squares and perfect cubes? You can use your calculator for this. What variables are perfect squares and perfect cubes? When we're combining, which means adding or subtracting radicals, we do that by combining like terms. When we're multiplying, we multiply the outside number times the outside number and the inside number times the inside number. And then when we have an exponent that's a fraction, the top of that exponent is always the power and the bottom is the root. And then when we're dealing with imaginary numbers, I is always equal to the square root of negative 1. I squared is always equal to just the number negative 1. And then if I have I to an even power, that will always simplify either to be positive or negative 1. And then if I have I to the odd power, that will always simplify to be positive or negative I. You have to work those out. Hopefully this will be helpful when doing any quiz or test from Unit 2. Let me know if you have any questions.